Hello all, welcome back. We're doing lesson 7 now, L'Hopital's rule, and I will have to just say that L'Hopital is awesome. Students actually like it because it simplifies a lot of limits that we have been doing recently. It does not simplify or apply to all limits, so my first goal is to show you guys when can you use L'Hopital, and then the second goal will be what to do to use L'Hopital's rule. So the first thing that I want you guys to understand is that you will have usually a rational function that you're taking the limit of, and both f and g have to be differentiable. And that just simply means that they have to be able to take derivatives. All right, you already know that from differentiability. We also have to assume that g of x is not 0, and then g double prime of x is also not 0. So we can't have a constant down here. And so what we're going to do here is we're going to look at the limit at the top, and if that's 0, or the limit at the bottom is 0, or if we look at the top or the bottom and the limits are positive or negative infinity, then L'Hopital is going to apply. So you've probably seen this in pre-calculus, but if you were to substitute in, all right, you substitute in and you get 0 on the top and you get 0 on the bottom, that's all that this is saying. So you substitute something in, you get 0 over 0. Or if a limit's approaching positive or negative infinity and you plug in infinity, you get infinity over infinity. L'Hopital also works here. All right, there are 7 indeterminate forms. In this lesson, we're going to learn 2 of them. And then a little bit later on in the course, we're going to learn the other 5, the weirder ones that you do. But let's go ahead and make sure you guys understand L'Hopital. So again, let's look at it. So the notation for L'Hopital is a little bit intense, but and I will show you guys how to do that here in a minute. But let's look, first of all, of when will we use L'Hopital. So you guys can see we have a lot of limits here, and so if you want to go ahead, first thing I always tell you guys to do is do substitution. So if you plug in -2 to the numerator, you're going to get 0, right? And you plug -2 into the bottom, you're going to get -2 squared, which is 4. You're going to get plus 2 times -2 times 3, which is -6. So 4 minus 6 is -2, and then plus 2 is 0. So you're going to get 0 over 0. All right, so the first thing I want to clarify really quickly is you never, ever, ever want to write equals 0 over 0, because this does not do that. All right, once you see you have 0 over 0, then you can use L'Hopital. Now over here, I'm going to just kind of ignore this for a second. I'm going to write this problem out again, because I want you guys to know that you've actually learned how to do this already. So remember I told you guys, okay, well, if substitution doesn't work and you get 0 over 0, you've already been trained to do this, then you usually have used algebra skills to solve the problem, right? So you get x and x, you factor this, and you get x plus 2 and then x plus 1. And so what you've done in the past is you've done these cancel out, and then you're left with the limit as x approaches -2 of 1 over x plus 1. You plug in -2 now to your substitution, and you're going to get that this answer is -1. So that is what you have done before, right? Lesson 2, we talked about solving limits algebraically. Well, let's show you how awesome L'Hopital is. Now, the first thing I want to say to you guys is that if you are going to use L'Hopital, they're going to have you guys do notation for it. And so the first thing that you have to show is you have to write that the limit as x approaches -2 of your numerator is equal to 0. You have to say that the limit of your numerator is equal to 0. And that's one of the suggestions that we have to have right here, right? You have to say that that limit is equal to 0. You also have to say that the limit at the bottom is also going to be 0. And so this is the only example that I'm going to show you all the notation, because it does get very tedious, to be honest with you. And right now, like I said, I just really care that you guys know how to do L'Hopital. So once you have said that the top limit is equal to 0 and the bottom limit is equal to 0, and really what that is that you've now verified that you have the indeterminate 0 over 0. Okay, that's what you've done. Then you're going to say, by L'Hopital, the hospital is what we like to say, right? By L'Hopitals. And you can spell, if you put hospital in here, it's totally fine. They're not going to care for it. Here's what you got to do. You have to then do the limit as x approaches -2 again. Don't forget about the notation. And now we just got to take the derivative of the top. So the derivative of x plus 2. So the derivative of x is just 1. The derivative of constant is just 0. Then you take the derivative of the bottom, and you're going to get 2x. And then you're going to take the derivative of 3x, you're going to get plus 3. And again, the derivative of 2 is 0. So you have this, and now you do substitution again. So what we've just did is we said that the limit, remember this is f of x in the top, and this is our g of x at the top. So if we get 0 over 0, then we can say that this limit is equal to the limit of the derivative of f of x over the limit of the derivative of g of x. And that's where this notation right here comes from. So this is what L'Hopital is. This is L'Hopital. That if you get an indeterminate form, 0 over 0, the near infinity, you can take the derivative and they're going to give you the same values, which I think is pretty awesome. Because when you see this, it's 1 over 2x plus 3. You just have to substitute in -2. And you're going to get 1 over, you put -2 in here, you're going to get -4. -4 plus 3 is -1. And no shock at all. You get the same answer as you got over here. So this is much, much, much easier than having to do your algebra skills now. So you've learned how to do it algebraically. Now L'Hopital is the best way to do it. I just got to stress really quickly that you always want to make sure that it is 0 over 0. All right, 0 over 0. So if this had ended up being 0 over 0, you would do it again. You'd find the second derivative at the top, the second derivative at the bottom, and you would keep going. But every time that you go to a limit, you have to check your values, right? Don't assume that you have to keep going and going until you get a value, just a numerical number in one of the top or the bottom. All right, so let me go ahead and erase some stuff and work on the next example. Okay, so let's actually look at example number 4. I wish we would 1, 2, 3, 4 like this. So we're going to look at example number 4. And again, ladies and gentlemen, if you plug in -2 into here, you're going to get -2 minus 4. And so I'm just going to say really quickly, you're going to get -6 on the top. So automatically, L'Hopital will not apply here. All right, it does not apply. All right, DNA does not apply because -2 minus 4 is -6. So then you just have to keep substituting in. You're going to get 4 on the bottom. You're going to get -2 times -2. It's going to give you a positive 4. And then you're going to get -8. You can get -6 over 0. All right, and so this limit just does not exist. So we had to give you guys an example in the problem here where what happens with this function. If it's not 0 over 0, and infinity over infinity, you do not apply L'Hopital. And students always do that, and they just make a silly mistake. So verify that you get this indeterminate. Okay? So let's look at, I'm going to go all over the place with these problems. So let's look at example number 5 now. Now, you guys haven't learned what the derivative of sine is yet, and so well, my AB students better know what it is. But just right here, I'm going to write down what it is. I would not expect you guys to be tested on this particular derivative right now because, again, I actually need to teach you guys that function. But you guys will find out in a couple of videos later, a couple lessons later, that the derivative of sine is actually just cosine. It's actually really awesome that it works out this way. And I'll show you guys that and why that is. And derivative of cosine is not sine, so just FYI on that. But it's close to it, but it's not. And like I said, my AB people, you already know what the derivatives are, and I know if you had me last year, then you know why the derivative of sine is cosine of x. We proved it in class. But anyways, long story short, let's go ahead and talk about L'Hopital. So if you look at the limit as x approaches 0, and so we're going to substitute in first. So the sine of 0 is just 0, okay? And then minus 0, so this top part is 0. If I plug in 0 to the bottom, I also get 0. So I know I can apply L'Hopital's rule in this particular problem. So the limit as x approaches 0 of the derivative of sine is cosine of x, and then minus the derivative of x is 1 all over 3x squared. Okay, 3x squared. And so we look at this problem and we say, okay, now let's plug in 0. We plug in 0 to cosine, and the derivative of cosine, or sorry, we plug in 0 to cosine. Cosine of 0 is 1. 1 minus 1 is 0. So we have 0 again. And then we plug in 0 here, we get 0 as well. So we have to do it another time. So actually, I'm going to show you guys what the derivative of cosine is. So the derivative of cosine, and I know my AB people know it already, it's just going to be equal to negative sine of x. Okay, it's negative sine of x. So let's go and do this one more time. So the limit of x equals 0, and this is going to be negative sine of x. The negative 1 goes away because the derivative of that, and then we're going to get down to 6x. So, ladies and gentlemen, let's look at this. We plug in 0 to this problem. We get sine of 0, which again is 0. We plug in 0 here, we're going to get 0. So yet again, we have another indeterminate. So we have to do it one more time. One more time. So the limit, but notice that I'm always checking as I go through my steps, right? I'm always going and checking to make sure that it actually works. So we still have our negative. The derivative of sine is already cosine, so we're going to put cosine in right here. And then we're going to go ahead and do the derivative of 6x is just 6. Well, now once we plug in 0 to the top, we're going to get 1, right? Cosine of 0 is 1. Well, we have a negative 1 on the top, and then we have a 6 on the bottom. So I know that you guys haven't been taught how to find the derivative of sine and cosine yet, but this is a really good way of showing you that we had to go multi-steps, right? So what we've learned so far is that this one required one step, right? You take the derivative of the top, the derivative of the bottom, substitute in, you're good to go, right? After you realize this indeterminate was 0 over 0. Well, the same thing with this one. You say, well, let's plug in -2. Oh, wait, this is not 0, right? And by the way, if infinity over infinity is when you're going to be substituting infinity. So we don't have to worry about that right now. So any of these four examples, we're just looking for 0 over 0. If you do not get 0 over 0, you're good. Whatever that value is, you're great. If this had been a 3, then this would have been -1 in the bottom, and it would have been just +6, right? It doesn't have to be, does not exist for this to work. And then for question number 5, I've showed you guys multiple steps to get to the answer. Okay? But hopefully you're getting the idea. L'Hopital is as simple as what you see right there. If you get an indeterminate form, you just keep finding the derivative of the top, the bottom, derivative of the bottom, and you check it. And if it's still 0 over 0, you keep going until it's not 0 over 0. All right? So if we look at example number 2, well, this one, if we plug in 0, we're going to get sine of 0, which again is 0, and then this is also 0, so we're in the form of 0 over 0. And so we're going to get the limit as x approaches 0. So the derivative of sine, we've already talked about, is cosine. Again, I'm not going to test you on this, but we're not done with this problem because I have a 5x right here. So this is the chain rule for trig. So again, we're just previewing a little bit more why the chain rule is so important. So you have to then multiply by the derivative of what's inside of the parentheses right here. So you have to multiply by 5. So it's like, and you guys can think about this. This is a function inside of a function, right? F of x is equal to sine of x, and g of x is equal to 5x. So you really have the function, you really have f of g of x, right? You take all of g and you put it into x. So this is why the chain rule applies. Again, I'm getting way ahead of myself here, and I shouldn't to do that, I'm sorry. So the derivative of sine of 5x is going to be 5 cosine of 5x. And then the derivative of 2x is 2. Well, ladies and gentlemen, I already know that I'm not going to do L'Hopital again because I've got a constant in the denominator. So I know I only had to do this one time and one time only. So all I got to do is I know my answer is going to have a 2 in the denominator. And so if I plug in, I got a 5 right here, right? Got the 5. And so what is cosine of 0? Because I'm going to plug 0 back into here. So cosine of 0 is going to be 1. So this answer is going to be 5 over 2. 5 over 2. And as a matter of fact, this is a good time to write something for you. This is a good time to write some stuff for you here. So the limit as x approaches 0 of sine of ax over bx is always going to be equal to a over b. Okay, so it's always going to be a over b. So that's done again. And I think we've actually did this in a previous video. I think I actually went over this theorem with you guys. And I told you probably in that video that when you learn L'Hopital, you will realize how easy this is to do. Okay? So hopefully you guys are good with these questions. That is it. I mean, that's the concept. That's what you're learning. It's pretty straightforward. At least I hope so. Right? So I know that you guys already know this answer because you know what you learned back in Algebra 2 pre-calc about end behavior. But let's show you why the answer is what it is. And how you know the answer is because remember you were taught, look at the highest degree of the numerator, highest degree of the denominator, compare those two, and then you should know what the answer is. But let's actually use L'Hopital to show you why it is what it is. So if I put infinity in here, I get infinity squared minus infinity minus 6. All right, so a billion squared minus a billion minus 6 is still a really big number. So that's still infinity. Infinity squared times 5 is also infinity. So what we're going to do is we're going to take the limit as x approaches infinity, and we're going to find the derivative, 2x minus 1 all over 10x. Okay, so the derivative top, derivative bottom, again, ladies and gentlemen, notation. Never ever lose that. We plug infinity in here. We're going to get infinity times 2, which is infinity, minus 1, infinity. We're going to then do 10 times infinity is also infinity. So we're going to do it one more time. We're going to get the limit as x approaches infinity of the derivative of 2x is just 2. The constant, -1, is 0. And the derivative of 10x is just 10. And so we now have a value, and we remember from our limit laws that the limit as x approaches whatever this number is of a constant, a number, it's just always going to be that number, right? So this is going to be equal to 1/5. And again, ladies and gentlemen, you already knew that because you knew that the highest degree of the numerator was equal to the highest degree of the denominator, and you knew that the ratio of the leading coefficients would be the answer. So now we're showing you through calculus why that is. Did you ever wonder why it was equal? Probably not, but now you know. Now you know. So it's L'Hopital's calculus. All right, let's look at the question number 6. And again, ladies and gentlemen, I'm going to have to use a derivative, and this is so easy. So the derivative of e to the x, all right, the exponential function e to the x is just e to the x times the derivative of x. So if I asked you guys to find the derivative of e to the 3x, and again, I wouldn't test you on this right now because I haven't officially taught you this lesson, but I'm just going to show you guys that these are pretty straightforward. Derivative of e to the 3x is just, you literally rewrite it, so e to the 3x, and then you're going to multiply by 3, the derivative of the exponent. That's it. That's it. That's it. That's it. Yay for those derivatives. E to the x, the derivative of e to the x, is obviously itself, and then the only other function that the derivative of itself is 0. So that's a cool little fact that you may or may not care about. But anyways, here we go. So let's look at this problem. If I plug in infinity here, I get infinity squared plus 5, so that's still infinity. If I plug in here, I get infinity plus infinity. So I get infinity over infinity. So we're going to go the limit as x approaches infinity. By the way, students may not know what this answer is because, you know, the highest degree, this is not a number down here. It's not a polynomial, so you can't do that. You can't do the rules like you do down here. By the way, again, if the highest degree was in the denominator, then you know your answer would end up being 0. And if the highest degree was in the numerator, then you would have a positive or negative limit. It would equal positive or negative infinity. All right, so back to this. The limit as x approaches infinity, you're going to go ahead and do 2x in the top. This is going to be 1 plus e to the x times technically 1 because the derivative of x is 1. And so again, we plug infinity here, we get infinity. We plug infinity here, we get infinity, and we add 1, we get infinity. So infinity, infinity, infinity. So let's move on to the next one. We get a limit as x approaches infinity, and we get 2 over e to the x. Okay, 2 over e to the x. So this is where you have to think. Okay, you have to think. We know L'Hopital is done. We know L'Hopital is completely done because the numerator is going to be 2. Okay, and so if I plug in infinity here, it's e to the infinity. And e is, remember, a number. So it's like 2.7 raised to the infinity. So that's going to give you a really big number. It's a really big number. So the limit of 2 over infinity. Well, what is this actually approaching? Right? What is this actually approaching? So this is not the right answer. So this would be our little side note work here. So our actual work would be here. What is this approaching? So the denominator is getting exponentially bigger. So what can you guys say about, I got 1 over 10, 1 over 100, 1 over 1,000, 1 over 1,000,000. What is this approaching? Approaching 0. It's approaching 0. And we can also think about that this is a functional dominance question. This is how we teach in AB calculus. It's a functional dominant question. E to the x looks like this. And 2 looks like this. Y equals 2, e to the x. E to the x is going to infinity. It's approaching infinity faster than that. This isn't even approaching infinity, right? Just going to be constant. So this is approaching infinity faster. Therefore, this is the power dominant function. Therefore, this is going to be just like down here. If I have given you guys the limit as x approaches infinity of x squared over 3x cubed, you know that this is going to infinity faster because it's higher power than this is, and that's why it's going to be equal to 0. Anytime that your denominator function is more dominant than your numerator, then the answer will always be 0. So let's look at these bottom 3. I would suggest that you guys pause the video and try them on your own, and then we can come back and do the problems together. Okay, so question number 7. Normally, what you have been taught to do for this problem is you would substitute in and you would get 0 over 0. And so again, never ever write equals 0 over 0. So this is a 0 over 0 function. And sometimes you guys will see, like, you can write it to the side just to acknowledge that. And remember, if for this one, again, I'm going to write it the correct notation for it, just the way that you would if it's an FRQ on the exam. You would see that this first part, the numerator, the limit of the numerator is equal to 0, and you would also say that the limit, it says expression 1 of the denominator is also equal to 0. So again, this is only if you're an FRQ on the exam. And then you would say by L'Hopital, right, by L'Hopital, then you can say that this limit here, the cubic function one, is equal to the derivative of the top and the bottom. So remember, this is just x to the 1/3 power, right? So this is going to be 1/3 x to the negative 2/3 power. And this is going to be equal to 1. And for this particular example, I know that I'm done here. I know that I'm done with L'Hopital because this is not 0. And so I don't have to worry about the exponent for this because thank God we're actually approaching 1. So this would just simply be 1. So this answer is just going to be 1/3. How much easier is that than what you guys did algebraically a couple lessons ago, where I told you that you would have to multiply by the conjugate? And you guys could, if you want to, you could go and finish this example up, and you know your answer would be 1/3. So L'Hopital now is an amazing way. And students ask, why do we have to go through all that algebra stuff? Because as we get through this course, your algebra skills still have to be incredibly well done. There's a lot of stuff that you can't do shortcuts for. So I have to make sure that you guys are really good with your algebra skills. And BC students, let's be honest, you guys are. You are. Okay, so hopefully you got 1/3 there. If you've not done 8 or 9, again, keep pausing whenever you want to, and let's continue on. So for this question right here, you see that I've got x, and then I've got some product. If I have a product, then, usually substitution is going to be fine, but you can also rewrite this. And when we get to the second lesson on L'Hopital, we're going to be doing a lot of rewriting before we start doing the problems. But we can go ahead and just do x and then bring this down and do 1 plus x squared, right? And so we can see if we plug in infinity, we get infinity over infinity. So this is infinity over infinity problem. This is infinity. Infinity plus 1 is still infinity, and squared is still infinity. So we can do the limit as x approaches infinity, 1, the top, right, the derivative. And then I like this because we can use the chain rule. So it's always nice to show the chain rule. 1 over 2 times 1 plus x to the first power, and then times the derivative of what's inside, which is 1. So we have the limit as x approaches infinity of 1 over 2 times 1 plus x. Again, ladies and gentlemen, we have 1 in the numerator. Our bottom is infinity, so it's 1 over infinity. Again, it's a bottom-heavy function, or the function dominance is in the denominator. Therefore, the answer is going to be equal to 0. Okay? The answer is going to be 0. So hopefully that makes sense. I know that students ask, okay, what if we flip-flopped it? I know I talked about it up here. What if I had the limit as x approaches infinity of 1 plus x squared over x? So now I'm top-heavy. So the limit as x approaches infinity of 2 times 1 plus x over 1. Well, you put infinity in here, infinity over 1. And since I'm approaching positive infinity, this is going to go to positive infinity. If this had been x approaches negative infinity, then this would be negative infinity. So really what this is, and now I don't want to say if this had been a negative 2, then this would go to negative infinity, right? Because this sign would end up being negative 2 times infinity. Hopefully that makes sense. I know that I'm kind of babbling here with this, but I'm always thinking about what questions students ask me for the particular examples. So top heavy, it's positive, negative infinity. Just look at your signs of your function and then what's also we're approaching down here. All right. Last example, example number 9. Okay, example number 9. And then I'm going to do one more quick thing, and then L'Hopital's done. There's one video for this. It's pretty awesome. So if we plug in 0 here, we're going to get 1. All right, 1 minus 1 is 0. This is going to be 0 over 0. So yet again, we know we're going to use L'Hopital. So the limit as x approaches 0, and so the bottom is just going to be 2x. And so this right here, this is just going to be 1 plus x to the 1/2 power. So we're going to use the chain rule, right? Chain rule. And I just want to say, just please be careful. If this had been 1 minus x, students always forget. If they just see 1x, they always think that it's done. So if this had been 1 minus x, then you would have to multiply by -1. So just, again, don't forget about the chain rule, even when it's pretty straightforward like that. Okay, so this goes away, right? The derivative of constant goes away. And this, students always want to use the quotient rule for this. This is the same thing as -1/2 x, right? So this is just going to be -1/2. So don't overthink that. Students just always think, oh, no, you don't do the quotient rule. There we go. So that's it. We're good. So the denominator is also going to be 0. If I put a 0 in here, this whole thing is 1, so I've still got 1/2 minus 1/2. So we have to do the L'Hopital one more time. And by the way, as I'm doing these two problems, yes, if these were FRQs, you would have to write this step, and this step for here, here, and here and here. And if you have to do it multiple steps, you're supposed to do this every single time. So I would not imagine that they would have multiple steps for this, ladies and gentlemen, because that just takes too much time. I mean, it really, really, really does. Okay, so the denominator is 2, and the top, I can get rid of the -1/2, right, because that's just a constant. Notice that I did not, and for L'Hopital, I never simplify things, ever, 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 ever. And I encourage you guys not to, especially if you're going to try to find the 4th, the 5th, the 7th derivative. You don't want to simplify, because now I can just easily move this -1/2 down, and I can get -1/4, and I get 1 plus x to the -3/2. And once I plug in 0, this is going to go away, right? Because this is 1 to some power. 1 to any power is just 1. So then I'm left with -1/4 divided by 2, or -1/4 times 1/2, or the right answer would be -1/8. So this crazy limit is -1/8. Okay? So that's it. That's L'Hopital. That's all you have to do. It's super straightforward. So let me show you guys one quick little thing here, little cool thing, and then we're going to stop the video. Okay, so I'm going to tie everything together. I'm going to show you 3 ways now that you have learned to solve this problem. 3 ways. The first way, the very first thing you learned was using algebra. You learned that, okay, if I plug in, I get 0 over 0. I can use my algebra skills. I know this is a difference of 2 squares. So these are going to cancel out, and you're going to be left with the limit as x approaches 3 of x plus 3, which is going to be equal to 6. So there's way number 1. Awesome. Okay. The second way that you learn is what I just showed you, L'Hopital. We know that, again, you get the form 0 over 0. So we're going to take the derivative of the top, which is 2x. We're going to take the derivative of the bottom, which is 1. We're going to substitute in now. 2 times 3 is 6. Awesome. And again, L'Hopital is fantastic. Look what you had to do. Not very much at all. The last way, and it's not going to be obvious, but this is actually the definition of the derivative. This is one of the forms of the definition of the derivative that you guys have already learned. So you guys can see this. And if you know this definition of the derivative, then you know that the function f of x is right here. So my function is x squared. The value I'm looking for, the c, is 3. And then once I take the derivative of this, f prime of x is equal to 2x. And I plug in f prime of 3, I get 6. So 3 ways to do one problem. Now, most of you, when you look at this, you're like, this is by far the easiest way to do it, right? The easiest way to do it. And that's why L'Hopital is awesome. But I just want to show you guys this. I like to tie things together. So 3 separate lessons you have now learned. 3 different ways to do this. I think this was lesson 2, this is lesson 7, and I think this was lesson number 3. So we're good. I hope you guys thought this was helpful, and I'm leaving you there. So good luck, and I'll see you guys in class.